In this video we will discuss thermochemistry basics. Now in thermochemistry we have a lot of different terms that we need to understand. First off is heat. Heat is the measure of the transfer of thermal energy. And thermal energy is part of that internal energy of a system. And temperature is the quantitative measure of how hot or cold something is, which is the manifestation of thermal energy, often associated with molecular or atomic vibration. Now, one of the more popular units for heat is the calorie. The calorie is defined as the amount of heat required to raise the temperature of 1 gram of water 1 degree Celsius. This is a very convenient method of measuring heat flow because all you need is exactly 1 gram of pure water. Another unit that we use for measuring heat is the joule, which is more common. The joule is defined from a kinetic energy perspective, but we can actually relate this to a heat energy by defining it against the calorie. 1 calorie is exactly equal to 4.184 joules. Now be careful, this calorie is different than the nutritional calorie. The nutritional calorie is actually 1,000 calories, and therefore 1 nutritional calorie is 4.184 kilojoules. Heat capacity, represented by the uppercase variable C, is the heat required to raise the temperature of an object 1 degree Celsius, and its units are joules per degree Celsius. So for instance, if we have this small skillet, which has a heat capacity of 300 joules per degree Celsius, we would need 300 joules in order to raise its temperature 1 degree. Compare this to this larger skillet, which has a heat capacity of 1500 joules per degree Celsius. If we wanted to raise the temperature of the skillet, say 4 degrees Celsius, we would need 6,000 joules. And as another example, we have the heat capacity of, say, a calorimeter, which in this example has a heat capacity of 50 kilojoules per degree Celsius. Now, this heat capacity is referring to the entire thing, the entire calorimeter. That includes the water, the thermometer, the stir, the housing, the jacket, everything. Compare this to specific heat capacity. Specific heat capacity is different. It's represented by the lowercase c, and depending on the textbook, sometimes lowercase s. And this is the heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. So its units are joules per gram per degree Celsius. Now, why the difference? Well, this is something that we can normally portion out in different quantities. So for instance, if we want to know how much energy is required to raise the temperature of, say, half a gram of iron, well, we would use its specific heat capacity and we would determine it to be 0.222 joules. Now, heat flow is defined by a couple of different equations depending on what you do. If we're talking about heat in or out of a substance, this is Q equals mc delta T. M for mass, lowercase c for specific heat, and delta T for the change in temperature of the substance. And if you're talking about an object, such as a calorimeter, this is Q equals big C delta T. In this case, you don't have to worry about the mass of the object. That information is wrapped up entirely in its heat capacity already. Now, if we take a look at the change in temperature, we notice that if we put energy or heat into a substance or an object, well, that means its temperature is going to go up. And as we know, delta T, or delta anything, is the final state minus the initial state. So if you put energy into something and its temperature goes up, then delta T is going to be positive, which is going to make Q positive, because mass and specific heat are never negative. This is how we know that we have an endothermic process. However, if heat is leaving the system, then the final temperature is going to be lower than the initial temperature, which means that the delta T is going to be negative, which is going to make Q negative. Now, we can have negative heat. Remember, this is heat flow. If we have negative heat, that means that we have an exothermic process. The last term is enthalpy. Enthalpy is a little bit more complicated. Enthalpy is defined as the sum of the internal energy of a system plus its pressure times volume. Enthalpy is what we really want to be able to measure. It'll tell us a lot about a chemical change. However, There's a lot more that can go on besides the transfer of heat. Work can be done. Work is pressure and volume. But we're going to conveniently ignore that. If we perform chemical reactions or some sort of change at constant pressure, then the enthalpy turns out to be the exact same as the heat flow. So we measure change in enthalpy. We cannot actually measure inherent enthalpy. We can measure the change in enthalpy. So if we can measure the heat flow in or out of a system, such as, say, melting some water, then we can determine its change in enthalpy. And just like heat flow, enthalpy can either be positive or negative. So in essence, if we know how much heat has flowed in or out of a system, we can know the change in enthalpy, which is also measured in joules, just like heat. So to summarize, heat is the flow of thermal energy. Heat capacity is the energy required to raise the temperature of an object, 1 degree Celsius. Specific heat capacity, or sometimes just specific heat, is the heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. And enthalpy is the change in thermal energy of a system at constant pressure.